Okay, today we're doing section 5.6, solve absolute value inequalities. Before, you solve absolute value equations. Now you will solve absolute value inequalities. Why? So you can analyze softballs compressions as in exercise 38. Key vocabulary: absolute value, equivalent inequalities, compound inequalities, absolute deviation, and mean. Recall that the absolute value of x equals 3 means that the distance between x and 0 is 3. The inequality, the absolute value of x is less than 3, means that the distance between x and 0 is less than 3. And the absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. The graphs of the absolute value of x is less than 3 and the absolute value of x is greater than 3 are shown below. Remember, the absolute value of x is equal to 3 means x can be 3 or x can be negative 3 because it's 3 units from 0 in either direction. Now look at the absolute value of x is less than 3. What does that really mean? Look over here. The absolute value of x is less than 3. That means that x is less than 3 and x is greater than a negative 3. Here's my graph. I'm at 0. All right, less than 3 would be 1, 2, 3. Less than 3 would be 1, 2, 3. Once again, units. Less than 3, 1, 2, 3. Back to 0. Less than 3, 1, 2, 3. Back to 0. And then see how I'm shaded right here. Also notice that here we say less than 3. We circled 3 but not shaded. We circled 3 but not shaded. Of course, that's a negative 3. But we circled a negative 3 and not shaded. Now come over and look at the graph of the absolute value of x is greater than 3. If I look at the absolute value of x is greater than 3, that means that x is greater than 3 or x is less than a negative 3. Look at it right here. X is greater than 3. I got my 3 circle, not shaded, greater than. I'm going in this direction. Now, once again, we're talking about units. Here, look at the negative 3, right? More than 3 units away, I'm going in this direction. More than 3 units away. So once again, absolute value of x is greater than 3 would be x is greater than 3 or x is less than a negative 3. Example 1, solve absolute value inequalities. Solve the inequality and then graph your solution. The absolute value of x is greater than 6, greater than or equal to 6. As soon as I see that it's greater than, I know it's going to be or. But the way I would write it out would be, I know I have two versions. X is greater than or equal to 6, and I have x is less than or equal to a negative 6. All right? The distance between x and 0 is greater than or equal to 6. So x is less than or equal to a negative 6, or x is greater than or equal to 6. Same thing I have written up here. Now notice, I get right here, I get 6, greater than would be 1, going in that direction, starting 1, 2, out that way. All right, greater than, once again, 1, once again, we're saying how many units away from 0, greater than, as far as the units. All right, let's look at this one. As soon as I see it says less than or equal to, I know it's going to be and. So I'm going to write x is less than or equal to a 0.5. And then I have x is going to be greater than or equal to a negative 0.5. Once again, repeating, the distance between x and 0 is less than or equal to 0.5. So a negative 0.5 is less than or equal to x, which is less than or equal to 0.5. Another way to read it is to read it from the inside out. X is greater than or equal to a negative 0.5. That's that one. And x is less than or equal to 0.5. That's that one. I graph, there's 0, 0.5, 0.5. Less than goes this way, and greater than goes that way. And that's my and. Reading. You can use the words between and beyond to describe absolute value inequalities. For example, the absolute value of x is less than 2 means that x is between -2 and 2. The absolute value of x is greater than 2 means that x is beyond -2 or beyond 2. Solving absolute value inequalities. Key concept. The inequality, the absolute value of a times x plus b, is less than c, where c is greater than 0, is equivalent to the compound inequality, a times x plus b is greater than -c, a times x plus b is less than c. The inequality, the absolute value of ax plus b, is greater than c, where c is greater than 0, is equivalent to the compound inequality a times x plus b is less than a -c, or a times x plus b is greater than c. In the inequalities above, less than can be replaced by less than or equal to, and greater than can be replaced by greater than or equal to. Example 2. Solve an absolute value inequality. Solve the absolute value of x minus 5 is greater than or equal to 7, and then graph your solutions. Okay, in solving example 2, first thing we're going to do is write the original inequality. That's what we got here. Rewrite as a compound inequality. That means a positive version and a negative version. So first I'm going to write x minus 5 is less than or equal to a -7, or x minus 5 is greater than or equal to a +7. I'm going to solve for x. And here I'm going to show you the steps that's missing over here. X minus 5 is less than or equal to a -7. I'm trying to get x by itself. So therefore, I'm going to get rid of this 5 by adding the inverse. What's the inverse of a -5? +5. +5 on this side, +5 on that side. This goes to 0. I'm left with x. -7 plus 5 will give me a -2. So x is less than or equal to a -2. All right, now my other equation, x minus 5 is greater than or equal to a 7. That's this one here. Do the same thing, +5 plus 5. Add going down, disappears. X is greater than or equal to 12. And then I graph each side. X is less than or equal to a -2. Circle the -2, shade it, back in the less than direction. Here, greater than or equal to 12, circle the 12, shade it, back into the greater than direction. Example 3, solve an absolute value inequality. Here we're going to solve the absolute value of a -4x plus 5, a -4x minus 5 plus 3 is less than 9. And then we got to graph our solution. All right, first we write the original equation, the original inequality. Then we have to get the absolute value sign by itself. That has to be left by itself. So to do that, I got to get rid of this 3 here. To get rid of this 3, I'm going to subtract 3 from both sides. All right, that means that's going to cancel out. And then I'm left with 9 minus 3, which is 6. All right, after saying that, now I have the absolute value of a -4x minus 5 is less than 6. Now I set my inequality equal to a positive version and a negative version. So we're going to write it as a compound inequality. So a -4x minus 5 is greater than a -6, and a -4x minus 5 is less than 6. Once again, because it's less than, I know it started off being less than, I know that it's going to be an and situation when I graph. But anyway, I'm going to add 5 to each side. All right, and adding 5 to each side. So here I'm going to say plus 5, and also plus 5. What do I get? A negative 6 plus 5 is a negative 1. A negative 5, when combined with a positive 5, that goes to 0. So I'm left with just a negative 4x. 6 plus 5 is 11. All right, now I do what? Divide each expression by what? Negative 4, and reverse the inequality symbols. So I'm going to divide each side by negative 4 here, negative 4 there, and negative 4 right there. All right, now what's a negative divided by a negative? That's a positive. What's 1 divided by 4? 0.25. What's a negative 4 divided by a negative 4? That's a positive 1. So I'm left with just x. What's 11 divided by a negative 4? 11 divided by a negative 4 is going to be a negative 2.75. I change my less than to greater than. I change my less than to greater than. So what is my final inequality? Once I rewrite it in the correct form, it's going to be x is greater than a negative 2.75 and x is less than 0.25. Then I graph my results. The solutions are all real numbers greater than a negative 2.75 and less than 0.25. And as you can see, this is our graph. Notice this and. See how they end up intersecting. Example 4. Solve a multi-step problem. Computers. You are buying a new computer and find 10 models in a store advertisement. The prices are $890, $750, $650, $370, $660, $670, $450, $650, $725, and $825. Find the mean of the computer prices. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your conditions? Step 1. Find the mean by dividing the sum of the prices by 10. The mean. Add up all the computer models. There were 10, so you're going to divide by 10. When you get finished adding, you'll come out with 6,640 divided by 10 is equal to 664. So that is going to be your mean. Step 2. Write and solve an inequality. An absolute deviation of at most 100 from the mean 664 is given by the inequality. The absolute value of x minus 664 is less than or equal to 100. Now make sure you understand what that means. At most 100. That means the most you have is $100 or less. So it's going to be less than or equal to 100. So you set up your inequality. You write out the compound, the positive version and the negative version. So x minus 664 is less than or equal to 100. And x minus 664 is greater than or equal to a negative 100. So then you solve, and you're going to do what? Do exactly what it says. Add 664 to each expression. So plus 664 plus 664 and then plus 664. All right, now negative 100 plus 664 is a positive 5664. A negative 664 plus 664 cancels out. So you're left with just x. 100 plus 664 is 764. So your final answer is x is greater than or equal to 564 and x is less than or equal to 764. The prices you would consider must be at least 564 and at most 764. 6 prices meet your conditions: 750, 650, 660, 670, 650, and 750. All right, that completes today's lecture, so you may begin your assignment.